After you do sequences, you're going to do series. So the sequence is the set of numbers, and the series is the sum of those numbers. And so here we're going to add 5 and 12 and 19 and 26. And if you notice, that's just going to go on forever. So anytime we do an arithmetic series, we only do a partial sum, which means we're going to add part of those numbers together. So the equation for the partial sum of the arithmetic series is the sum of n terms equals n over 2 times the quantity of the first term plus the nth term. So let's go ahead and find the sum of the first 15 terms. We have n over 2 times a sub 1 plus a sub n. So we have to go find a sub 15 before we finish this problem. So the 15th term is 103. This formula so the sum of the first 15 terms is 810. We're going to find the sum of the 7 terms. So here we have 3 and you take it times 5 to get 15, and you take that times 5 to get 75. So this one is a geometric sequence, which means we're talking about a geometric series. Now, so the partial sum in a geometric series is this one right here. It's a partial sum again because we'd be adding a bigger number each time, which means we're going to get infinity. So we want to find the sum of the first 7 terms. So our first term is 3, the common ratio is 5, n is 7, and the common ratio is 5. Here we have an arithmetic series and a geometric series. Now, these both diverge, which means that they are going to just get bigger and bigger and bigger and get to infinity. In series that diverge, you're only going to be able to find a partial sum. This series will converge, which means it will actually get to a certain number. So notice the difference between this geometric series and this geometric series. This one is multiplying by a certain number, and this one is multiplying by a number that's smaller than 1. So if you want to think of it as dividing, that's okay, but formula-wise, you got to realize that you're multiplying each of these by 1/2. Okay, so just looking at the numbers, we're going to add the next term. So we start with 64. We're going to add half of that, which is 32. Okay. Then we're going to add 16. And then we're going to add 8. And so notice that is getting bigger. And then we're going to add 4. I stopped recording and didn't realize it. So we added 4, and then 2, and then 1, and then we added 1/2. And then we added 1/4. And you'll notice that the number is still growing, but not very fast anymore, because look at what number it has been for a few steps. We keep adding half of the number, and so we're getting very, very close to a particular number, which is because when the common ratio is smaller than 1, the geometric series will. We can find a sum for a series. We don't have to find just the partial sum. Your sum is a sub 1 over 1 minus 1. So your first term over 1 minus the common ratio, which was 1/2. If you add all those up, you're going to get 128, which is what we were getting very close to in the calculator.